Today we start first chapter of Pure Mathematics 3, and it's very important for you to know that when we are doing Pure Mathematics 3, it means we need to cover all the chapters for Pure Mathematics 2, and then we have other chapters to cover to make it that we are studying Pure Mathematics 3. Well, the first chapter is about algebra, and algebra is a very important section in mathematics. And it's amazing the use of algebra because we use it everywhere. In astrophysics, to describe galaxies, to calculate the wave propagations, and any other general calculus. And it's amazing that, well, the most famous one that he used algebra is Albert Einstein. And one amazing use that he used algebra in is that he managed to calculate or to prove that there is a certain planet at a certain position. Even he didn't see it, okay? He didn't have the equipment to see that planet, but he proved that this planet exists and it should be at that position just using algebra. This is so amazing because you would be able to prove the existence of things without even seeing them, right? And you will see later when we say that, yeah, I'm solving this algebraically, it means that you don't need to see graphs, you don't need to see anything, just using numbers, just using expressions, and you will be able to solve a lot of complicated things. And yeah, I like this part of mathematics because just the paper and a pen and you will be good to solve whatever hard problem. Well, anyway, this is how important algebra in mathematics, right? But before being able to solve complicated problems like that, we need to know all aspects of algebra, okay? And we saw how to solve equations, linear equations, quadratic equations, and inequalities. But a very important part is how to solve functions or equations involving the modulus functions. But before doing that, we need to ask ourselves, what is a modulus function? What is the modulus? So the modulus of a real number is the magnitude of that number, okay? And it means the positive value of that number, right? So for any real number, the modulus of x, that we write x between two straight lines like that, we read it as mod x, right? So mod x is the positive value of x. For example, if I will say the mod 4, it means I need to get the positive value of 4. 4 is a positive number, so mod 4 is equal to 4. And if I will say what is the mod of negative 4, so the mod of negative 4, I just kick that negative sign there, and the mod of negative 4 is 4. So I just need to write like that. Now, in general, if we are dealing with inequalities like that, if I say that mod x is less than 2, this means that x should be between negative 2 and 2. And this inequality is very important for you later, okay? Because it will help us solve a lot of problems, okay? So another thing, if I will say that mod x is more than 2, this means that x is more than 2 or x is less than negative 2. You need to remember that, yeah, to make the mode of x a positive number, this positive number, it means that x is maybe a negative number that is less than negative 2, okay? Because I know that negative 3, for example, mode of negative 3 is 3, and 3 is more than 2. So just remember these two, they are very, very helpful. So in general, just put in mind that mod of a positive number, it's that positive number. Mod of negative number is minus that negative number, right? let's take in general how to plot the modulus function. So the modulus function is for x, we map mod x. It is defined for all x's that are real number. And how to plot this? Well, I start by plotting the function y is equal to x, so this straight line here. And then I know that for all x more than 0, mod x is equal to x because it's a positive number. So this is part of the function mod x. Now for x negative, for x less than 0, we know that if x is less than 0, mod x is equal to negative x. It's because negative x is a positive number here, right? Since x is a negative number, so negative x is a positive number. And yeah, it's like I'm doing the reflection of this line here in the line y is equal to 0, or the x-axis, right? So to plot the function fx is equal to mod x, I just need to plot the line y is equal to x, keep the part when x is equal to 0, when x is more than 0, and then do the reflection of the part when x is negative in the x-axis, right? Well, always remember, I always tend to say to my students that the modulus function is v for victory. Okay, so it's the letter v like that. So just remember it. Just plot the first bisector, and then reflect that in the y-axis or the y-axis or the x-axis. Up to you. So it's like I'm doing the reflection in the y-axis for this part, or I'm doing the reflection in the x-axis of this part. So it's up to you how to see it, right? Just remember this part, that mod x is equal to x for x positive, and mod x is equal to negative x for x negative. This is how we define the mode function. Now, another example, imagine I would like to plot the function y is equal to mod x minus 1. So first, I need to plot the function y is equal to x minus 1. I just keep the part where y is positive. It means I need to see where this part is equal to 0. Well, y is equal to x minus 1 is equal to 0. It's when x is equal to 1. So when x is more than 1, this part is positive. When x is less than 1, this is negative. Y is negative. So I just need to reflect this part in the x-axis, right? So this is exactly what I did here. And this is a little note for you. If fx is negative, then the mode of fx is negative fx. It may be weird, but just keep in mind that fx is negative here. So negative fx is a positive value. This is why I have mode fx is equal to negative fx. Right. Well, this is one of the problems that you will face in exercises. They will ask you to plot functions like that. Now, another type of questions that you may face is they will ask you to solve equations like that. So 3x mod 3x is equal to mod x plus 2. How to solve this? Well, there are plenty of methods, and I will explain here 3 methods how to do that. The first method is we do it graphically. So how we do it graphically? You just need to plot the 2 functions. So I will plot mod 3x and I will plot mod x plus 2. So this is mod 3x in green, and this is mod x plus 2 in blue, right? Now I know that at the point A, this is a point A, and the point A and B are the points where the 2 graphs meet, so the meeting points. So at point A, I have that x plus 2 is equal to negative 3x. Why it's equal like that? Because this line is y is equal to x plus 2, and this line is equal to y is equal to negative 3x, okay? Because since this is the part where I need to take the reflection of the line y is equal to 3x, so this is why this part is equal to negative 3x. Right, so I have the two lines are meeting, so the equations, the meeting point would verify the two equations. This is why I wrote like that. And using this, I can get exactly the value of x, or the first coordinate of the meeting point. So just reformulating this function or this equation, I would get that x is equal to negative 1 over 2. So this is the first coordinate of A. And this is the first solution, okay? I just need to read the first coordinate of the first meeting point. The second solution, it's B, the meeting point here. It will be the meeting point of the line y is equal to x plus 2 and the line 3x. So I just need to write the two inequalities here, the equality here, the two equations. So x plus 2 is equal to 3x. Just managing that, I will get that x is equal to 2. And yeah, normally x is equal to 2 is the solution here. Well, x is equal to 1, not 2. Yeah, because it will be 2x is equal to 2, so x is equal to 1 here. And not 2. And even on the graph you can see it, right? So sorry about that, it's 1, not 2. All right, well, this is the first method, so just graphically, and you will see the equation, the solution directly from the graph. A second method is, yeah, I have two numbers or two expressions that are equal, and then I can take the square of these two parts. So the square of this is equal to the square of this. And when taking the squares, it's just, I can transform these two straight lines on brackets, because I know that this is a positive number and I know that this is a positive number. So taking the squares of these two will not change anything, because this is a positive number and I know that square is a positive number too. So, and the second thing I should do is to expand the brackets here. So just using the formula a plus b squared is equal to a squared plus 2ab plus b squared, and yeah, I will get something like that. And I need to rearrange this expression here. So if I send x squared to the other side of the negative sign, and I will do the same thing for 4x and 4, I will get the simplified form like that. Well, 8x squared minus 4x minus 4 is equal to 0. But as you can see here, I can put 4 as factor, and I can divide both sides by 4. So doing that, I get rid of the 4 here. So 8x squared divided by 4 is equal to 2x squared minus x minus 1. This is simplified form. And after that, I will factorize this, because it's a quadratic equation here. So one way to solve it is to factorize it. While factorizing it, I will get that 2x plus 1 is equal times x minus 1 is equal to 0. So solving this, it means the first part is equal to 0, the second part is equal to 0. So 2x plus 1 is equal to 0, or x minus 1 is equal to 0. So solving these two, I get that x is equal to negative 1 over 2, or x is equal to 1. So I got normally the same results as before. And I can use this method because I have x inside the two straight lines here. If x is outside, I can't. Okay, so just be careful, because I won't get rid of the modulus sign if x is outside, right? And it will be a problem. Well, I can show you an example for that if you wish during the Zoom session. Right, the third way is to use that if I have the modulus of mod A is equal to mod B, then A is equal to B, or A is equal to negative B. If they have the same modulus, then they are positive, they are both of them equal, or they are both of them, one of them is the negative version of the other number, right? So I will use that. So I have x plus 2 is equal to 3x in mode. So mod x plus 2 is equal to mod 3x. This means that I have x plus 2 is equal to 3x, or x plus 2 is equal to negative 3x. So now I have two equations to solve. So if I will rearrange this, so if I will send x to the other side with a negative sign, I will get that 2x is equal to 2. And if I will send x to the other side, it will go with the negative sign. So I will have negative 3x minus x. So it's negative 4x is equal to 2. Just dividing both sides by 2 here, I get x is equal to 1, and dividing both sides by negative 4 here, I will get that x is equal to negative 1 over 2. So I got the same results as before. And be careful here, I can get the same result by doing 3x is equal to x plus 2, or 3x is equal to negative between brackets x plus 2. So it's up to you which side you take to add and remove the negative sign. It's up to you. Right. In the upcoming videos, we will see more complicated examples for how to solve inequalities when we are using the modulus. Okay. So yeah, stay tuned and see you. Bye-bye.